Welcome guys to the lesson 4.3 where we're finding zeros and writing functions. Basically in this section we are taking everything that we've gathered from chapter 2 to chapter 3 and parts of chapter 4 to determine the zeros of our graphs. And so how this is going to really is to allow us to easily find the zeros so that we can later on graph them, which we will do in section 4.4. Now you ask, well, how are we going to do this? Well, the first part says to find all roots, and it doesn't really matter how you find it. You could do the quadratic formula or completing the square from chapter 2. You can use the synthetic process that we learned in chapter 3, or what we just learned in 4.2 was doing the rational zeros and finding possible zeros and going from there. Now you're going to ask, how do I know which one to use? Well, that's up to you. Okay, eventually you will find which one will work. And so hopefully we can take a look and see how we can make that work for you, or how you can better find a way to make that work. Okay? So what needs to happen is we're going to take a look at the first one. So example A. Well, we have three terms, each of them with an x. So I'm probably going to go ahead and start with factoring out a GCF. And so if I factor out a GCF of x, I'm going to get x times x squared minus 6x squared, or 6x, excuse me, plus 7 is equal to 0. Now, I definitely know from here I have that x is equal to 0. So there is one of my solutions. Now on the other one, there is somehow, somewhere, we're going to do something. So if I'm looking at that, well, you know, if I did the p's or the q's, I'm going to plus or minus 1, plus or minus 7. That's really not going to get us any zeros. If I did the factoring method, there is no factors of 7 that will get me negative 6. I mean, it's either 8 or negative 8, depending on which way you go. So the only other option would be, in this case, would be to use a quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So what I'm going to do there is I'm going to do negative of negative 6 plus or minus the square root of negative 6 plus or minus 4 times 1 times a positive 7. Not sure why I put a plus or minus there, so we'll go ahead and erase that. That way that is correct. That should say minus there, so my fault there, guys. All over 2a, or in this case 2 times, in this case is 2 times 1. So that's going to be a positive 6 plus or minus 36 minus 28 all over 2. Well, that's going to get me a 6 plus or minus the square root of 8 all over 2. Well, if I recall, 6, the square root of 8 ends up being the square root of 4 times the square root of 2 all over 2. Well, I know that the square root of 4 is 2, so this ends up being 6 plus or minus 2 root 2 all over 2. Last but not least, I need to make sure that I reduce my coefficients. So what goes into 6, 2, and 2 evenly? Well, that's going to be 2. So 6 divided by 2 is 3. 2 divided by 2 is 1. So 1 root 2. So again, I have x is 0 as one of my solutions. And my other x values are going to be 3 plus or minus root 2. Notice that with these solutions, I can actually have my 3 zeros just by looking at, again, the power of my polynomial. So because it's a power of 3, I should have 3 zeros, okay? Or at least that's my goal. Okay. Make sure that you get all of this copied, and then we're going to go ahead and take a look at step B, or example B. Alright, so in example B, we're looking at 3x squared plus 2x plus 5 is equal to 0. Well, there's no GCF, so my other possibilities would be to factor. And if I were to factor, if I were to think in my head, there's really nothing possible that would actually get me a solution. And so what we're going to do is we're going to use the rational method, right? So again, the rational method was the P over the Q. So in this case, my constant is a positive 5, which leads me to say that I have plus or minus 1 and plus or minus 5. My Q, which is my leading coefficient, which is 3. So that tells me that I have plus or minus 1, plus or minus 3. So then, if I were to do P over Q, I would get plus or minus 1, 1 over 3, or 1 over 1 is the 1, 5 over 1 is plus or minus 5. Then I'm going to go to the other Q, and I got 1 over 3, so that's plus or minus 1/3, and plus or minus 1/5. So those are going to be my possible zeros. Now what we're going to do is we're going to take a look at this. Okay, so like I said, there's no way that we can factor this, and it's just not going to work, right? And so what you could do is, we're going to try this method, right? Okay, well with this method, if I did 1, then I did 3, 2, and 5, doing some fast math, I can get 3, 5, and, well, that's 10. That's not going to work. So, I got 5, right? If I did 5, then with these possible numbers, I'm going to look at 3, that becomes 15, that becomes 17, and then this becomes 85, so this becomes 90. Well, these numbers aren't going to work, so if I look at negatives, if I look at negative 1, I got 3 and a 2 and a 5, so that's negative 3, that's negative 1, so again, that's 6, so, we're really not getting anywhere with these numbers. So what are we going to do? Well, that's not going to work. So if I tried negative of 2 plus or minus the square root of 2 squared minus 4 times a times c all over 2a, which is 3, I'm going to get negative 2 plus or minus 2 squared is 4. Well, 4 times 5 is 20. 20 times 3 is 60. So minus 60 all over 6. Well, okay. It's going to get us negative 2 plus or minus negative 56 all over 6. Well, already I can see that I have an imaginary number. Well, there's no such thing as imaginary numbers. So in this case, that's going to tell us that we have no zeros, or in this case, no roots. So this function has no roots. So this seems like a lot of work, right? And how do we know it's not going to ever work? Well, again, like I said, if you know how to use your graphing calculator, if you can use your graphing calculator to double check to make sure. Now, in this case, this is really hard, so this is a lot of work. So my goal is on the test that you won't have any zeros or solutions or problems that says no zero or root. So that way we can assure that you're always looking for some kind of root. Okay? Alright, so as we move forward to examples C and D, we're looking at something that looks a lot like what we did in section 4.2, and that was called the U substitution. Okay, so again, just to remind us, U substitution is where we take the letter U and replace it with something else in our equation, so that's easier to work with. Now, these two equations, you can definitely use the P or the Q and make sure that you're in standard notation, okay? Or you can try to factor these. Now, if you're really good at factoring, you can definitely factor and it will definitely work. But if you're not sure on factoring, that's okay. You know, we'll make it easier so that we can factor or use a quadratic formula. So, just to remind us again of how that actually looks, I'm going to say that U is going to equal x squared. Now, if U is equal to x squared, then I could go ahead and replace it in my equation. So I could say that 3 times U squared plus 14U minus 5 is equal to 0. Okay, so again, I'm taking the letter U and replacing it with the x squared. Okay, now with x to the 4th, okay, I have twice the amount of x squared, right? So that's going to be to the power of 2, so that means U squared would get us U to the 4th. So that's how I got the U squared down here at the bottom. Okay. Now this makes it a little bit easier for us to factor, and if I were to factor, I know that I got a 3U times something times a U equals to 0. How do I know that? Well, if I were to FOIL, 3U times U is 3U squared, right? Okay, just a nice reminder on how to factor there. Well, now I need factors of -5, well, 1 and -5, or 5 and -1. But I still have to somehow to get to 14. So I'm probably going to do a -1 plus 5. Because if I did that, I get a -1U. Out here I get 15U, and together that gets me 14U. Right? So that works out really well. Well, now that I have these more simplified in terms of factoring, can I really factor these binomials any further? Well, let's take a look. 3U minus 1, can that factor any further? Not at all. U plus 5, can that factor anymore? Not at all. So at this point, we're going to go back and we're going to do the substitution again. Except this time we're going to plug in the values that it was before. So U is x squared, so I have 3x squared minus 1 times x squared plus 5 is equal to 0. Well, now what am I going to do? Set them equal to 0. Well, these are easier to set equal to 0, so all I do is set each one to 0. So 3x squared minus 1 is equal to 0, and x squared plus 5 is equal to 0. Well, on the left side, in order to get x by itself, I'm going to add 1 to both sides. So I get 3x squared is equal to 1. Divide by 3, so I get x squared is equal to 1/3. Right? So with that, then I do the square root. Well, x is then equal to the square root of 1 over the square root of 3. Well, here's a problem. I can't have the square root of 3 on the bottom, so what I want to do is we're going to rationalize, right? So to rationalize means to multiply the top and the bottom by the square root that's down there. So in our case, it's the square root of 3, right? Well, when I take the square root of 1 times the square root of 3, I get the square root of 3. Square root of 3 times the square root of 3 is the square root of 9. So this equals 2 the square root of 3 over 3. Now there is one thing that I do want to mention though, that I didn't place in here, and that was the one important sign. And when we do square roots, we should know that we should have a plus and minus. Right? So that means x is equal to plus or minus root 3 over 3. Alright, now on the other side, we're going to do the same thing. X squared is equal to negative 5. And the other solution would be, oh my goodness, we have x is equal to plus or minus square root of negative 5. Well, wait a minute, I can't have a negative square root of 1, right? And if you remember from chapter 2, the square root of negative 1 is I. Right, so we have x equals plus or minus square root of negative 1, square root of 5. We just pulled it out. And so we get plus or minus I root 5. Okay, so they're really not our zeros, but because that's how we solved it, that's what we get. So x is equal to plus or minus root 3 over 3 and plus or minus I root 5. Okay. Make sure to pause this video if you're needing to take a look at the problems or need to figure out how we did that again, or back and rewind and just to see that again. Okay. Now, if I were to move on and go to D, I'm going to do the same method as I just did in C. So I'm going to go a little bit faster this time. Okay. Again, we're going to use the U substitution. So U is equal to x squared. Okay. So I get 2 times U squared plus U minus 6 is equal to 0. I'm going to factor this out. So I know I get a 2u and a u is equal to 0. Okay, so I know that 2u times u is going to get me the 2u squared. So that's a good thing. Okay. So, not sure what just happened to my screen there, but we'll go ahead and plug that back in. So we get 2u squared plus u minus 6 is equal to 0. And so that we said 2u times u. And so now I need negative 6. Well, factors of negative 6 would be like 3 and 2, 1 and 6, right? So somehow I gotta get positive 1. Well, if I did 3 and 2 here, that gets me 4 on the outside, 3 on the inside. In order to get a positive 1, I need a positive 4 and a negative 3. So I get 2u minus 3 and u plus 2. Again, we can't really factor these out anymore, so I'm going to go ahead and substitute the x squared back in. So 2x squared minus 3 times x squared plus 2 is equal to 0. Which means that, well, I can't really factor anything else out anymore. So I get 2x squared minus 3 is equal to 0, and x squared plus 2 is equal to 0. Okay. Add 3 to both sides. Whoops, meant to be a 2 there. So 2x squared is equal to 3. Divide by 2, so x squared is equal to 3 halves. Take the square root, and x is equal to the plus or minus square root of 3 over the square root of 2. If I were to rationalize that again, I'm going to multiply by root 2 over 2. So then I end up with x is equal to plus or minus root 6 over 2. Okay, sorry for the computer glitch here, guys. Let me just go ahead and get that in there again, just in case. So 2x, so there it is. So I get root 6 over 2, right? All right, so and then on the other side here, what's going to happen is we're going to look at the other side. So we're going to subtract 2, so we get x squared is equal to negative 2. X is then equal to plus or minus root negative 2. Well, pull out the negative, so x equals plus or minus root negative 1 times root positive 2. Square root of negative 1 is I, so x equals plus or minus I root 2. So therefore, if I were to combine my solutions, I know that I get x equals plus or minus I root 2 and plus or minus root 6 over 2. And there are my 4 solutions to my equation. Okay. Alright, so before we turn to page 2 of this section, if you can tell, this is kind of a tedious section in the fact that we really don't know a straightforward direction on how to go. And so my suggestion is really figure out how you like to solve these. Okay, so again, going back, if you have a graphing calculator, you can use a graphing calculator to help you find your zeros or to help you determine if you're on the right track. Okay, and again, like I said, on the test, you will have problems where you won't have ones that say 0 or no zeros, but you'll have some kind of solutions, and so we'll kind of take a look at that. Okay. Now on page 2, we're going to do the exact opposite. Okay, so before on the front side, we had to find the zeros, meaning you started with the polynomial, you factored, or you did division, or you did the quadratic formula, or something in order to get to your zeros, right? X equals something. Well, on the back side, we're given the x equals something, and we're going to work our way backwards so that we can get to the polynomial function. Okay, so now how is that going to happen? Well, in order to get that to happen, we are going to take all of the ones that we have here, and we're going to make it work. Okay, so what do I mean by that? Well, okay, so if I were to take my a, I know that x is equal to 1, I know that x is equal to negative 3, and x is equal to 2i, right? So what I could do is make this really easy, and I need to make these into a binomial. So what I mean is, it has to be x plus or minus something is equal to 0. Okay, so how are we going to get x equals 1 to say that's now equal to 0? Well, I'm going to subtract 1 from both sides. So when you subtract 1 from both sides, you get x minus 1 is equal to 0. X equals negative 3. Well, I want that to equal 0, not negative 3. So how am I going to do that? I'm going to add 3 to both sides. So you get x plus 3 is equal to 0. Now over here, I get a 2i. Well, how do I get I? Well, I know that I is equal to the square root of negative 1. Oh, well, if I have a square root, then I also have a plus and a minus. So if I have a plus and a minus, that means I have, in order to get to this is 0, I have x minus 2i. But again, because I have a plus and a minus, this also means I have an x plus 2i. Okay. So now with all of these, what I'm going to do is I'm going to take all of these binomials and multiply them together. So I got an x minus 1, x plus 3, x minus 2i, x plus 2i. Okay. So let's FOIL the first two together. So I get x squared plus 3x minus x minus 3. If I were to FOIL the second ones together, I get x squared plus 2xi minus 2xi minus 4i squared. Okay, well, let's combine the first two, so the first one, so I get x squared plus 2x minus 3, and on the other one I get x squared, the 2xi and the negative 2xi, that's going to cancel out, minus 4i squared. Well, if you recall, 4i squared, well, I squared is negative 1, so x squared plus 2x minus 3 times x squared minus 4 times negative 1. Well, that's basically saying x squared plus 2x minus 3 times x squared plus 4. Okay, so I'm going to distribute, and when I distribute with each one, I'm going to get x to the 4th, because I took the x squared times the x squared, plus 4x squared. Then I get a 2x cubed plus 8x plus 8x, excuse me. Then I'm going to get a negative 3x squared minus 12. So if I were to combine like terms, I get x to the 4th plus a 2x cubed, and I'm going to get, I got a 4x squared and a negative 3x squared, so minus x squared, or excuse me, plus x squared, then plus 8x minus 12. So there is my polynomial. Okay. Now, if I'm to look at this, going from bottom to top, I started with a polynomial, and then I factored it, and I kept factoring until I got to where I get to my zeros. Okay, so all I did was I literally just worked backwards from the zeros to the polynomial. Okay, now don't quite freak out so much so yet. It's because of that 2i, right? Well, it's just like anything else. Okay. Just set it equal to 0, and then you multiply all of those binomials together. Okay. So if we're looking at B's a little bit easier. And so if we're looking at B, then we can say, okay, well, I know that x equals negative 2, and x equals 1. And I also know that I have x is equal to 3. So if I were to change these into the binomials, I get x plus 2, x minus 1, x minus 3. Okay, again, if you set them equal to 0, you would see how I get those binomials. And so we're just going to take the binomial part and multiply them together. So I got x plus 2 times x minus 1 times x minus 3. It doesn't matter which order you have, and it doesn't matter how you multiply them, because when you multiply them, the commutative property of multiplication says no matter how you multiply it, you're going to get the same thing. The associative property also says you can change the order or change the grouping and you still get the same thing, right? So if I were to FOIL this, I get x squared minus x plus 2x minus 2 times x minus 3. Okay, and if I were to simplify that, I get x squared minus plus x minus 2 times x minus 3. I'll distribute through and you get x to the 3rd plus x squared minus 2x minus 3x squared minus 3x plus 6. Okay, so I'm going to get something like x to the 3rd minus 2x squared minus 5x plus 6. Okay, and there's our polynomial. So this one was a little bit easier because we didn't have the i's in there. But if we had a square root or something, it'd be pretty much the same thing, right? Okay, and there you have section 4.3, where we found the zeros using any method that we've known since chapter 2, and then we've also learned how to write the polynomial functions. Okay. Make sure that you have all of these notes copied there and you can understand them. If you still don't understand it, make sure you go look at Khan Academy and our YouTube videos to better understand how to find zeros and roots of polynomial functions, and how to also write polynomial functions given the zeros.